Okay, YouTube, in this video, this is going to be an introduction to the tangent graph, or the graph of y equals tangent of x, where, again, x represents some angle, okay? So all the points on this graph, I want you to know we're going to represent some angle, okay, that we're plugging in, and then some y value you get when you take the tangent of that angle. And you notice here that I've already got a table set up on the left, and we're going up by pi force increments every time. That is, we're going up by 45-degree increments every time, and we're going to be utilizing this unit circle heavily, okay? So one property of the unit circle that I wanted to, well, maybe not the unit circle, but one identity that we should be familiar with if we're going to be discovering or exploring, excuse me, the tangent graph is this, that recall that tangent, y equals tangent x, the tangent of an angle is equal to the sine of that angle divided by the cosine of that angle. And the reason why I mention this is because, well, if you're looking at the unit circle, there are no tangent values on this graph, only cosine and sine values respectively. So what we're going to need to do is, for every angle that we're finding the tangent of, we're going to take the y value of that angle divided by the x value of that angle to get the tangent value. Okay, so let's go ahead and do this. We say, all right, 0 degrees or 0 radians. If we were to say, what is the tangent of 0? So I'd go over to 0 degrees. I'd say, well, that's y over x, or sine over cosine. We get 0 over 1. 0 over 1. So to be very, very explicit about it, we can say 0 divided by 1. We get a y value of 0. Okay. How about pi fourths? Well, pi fourths, looking at the unit circle, pi fourths are 45 degrees. The tangent of 45 degrees would be radical 2 over 2 divided by radical 2 over 2, or really radical 2 over 2 divided by itself. So we get a tangent value of, ooh, cool, 1. Now pi halves, and this is the interesting one here, and the reason why is because what you'll see is this. At pi halves are 90 degrees. If we're going to take y divided by x, we get 1 divided by 0, which of course is undefined. But really what we could necessarily infer from this is, well, tangent is always going to be undefined anywhere that, that x would be 0, because if we're taking y divided by x or sine divided by cosine to get tangent, then anytime cosine is equal to 0, we're going to get a tangent value that's undefined. So we say, all right, so tangent at pi halves is undefined. We'll talk about how you would necessarily put that on a graph. So 3 pi fourths. Okay, so 3 pi fourths. We say 3 pi fourths is 135 degrees, if you want to go degrees, right over here. If we found the tangent of this, it'd be positive radical 2 over 2 divided by negative radical 2 over 2. In other words, we'd get negative 1. And then we say pi. Pi radians, okay, so pi radians would be a 180-degree angle. The tangent of this would be sine over cosine, or 0 over negative 1. We get 0. And then 5 pi fourths, down here in the third quadrant, 5 pi fourths, 5 of these pi fourths things, or 225 degrees, we say negative radical 2 over 2 divided by negative radical 2 over 2, we actually get positive 1 again. And we say, okay, so 3 pi halves, 3 pi halves. Notice this, at 3 pi halves we have a cosine value that is 0, so when we try to find the tangent of 270 degrees, or 3 pi halves radians, we're going to be taking something divided by 0. We again get something that is undefined. Okay? And so if you're looking at this table like I am, you'll notice that it went from 0 to 1 to undefined to negative 1 to 0 to 1 to undefined, and one might necessarily infer that next we are going to get negative 1 again. And then from negative 1, what came after negative 1 last time? 0 again. And you know, we can just go back over to the unit circle to verify this. At 0 or 2 pi radians, if we took the sine divided by cosine, you get 0 divided by 1. Again, you end up at 0. So often when we talk about sine and cosine graphs, we talk about their period. Well, the period of tangent would be how many input values, or the length of the input value for which I could plug in and end up with the same y value again. That's not a very good way of saying that. Let's put it this way. I started off at a y value of 0, and I go through all of these other y values till I get back again to a height of 0. And then after this, if you were to notice, I mean, from here to here, I would just repeat. I would just be repeating the y values. So we say it took from 0 to pi to plug in for our y values to start repeating again. Or we could say from pi to 2 pi, that's also a length of pi radians. So we'd say the period of tangent is pi. Okay, and that's one thing we want to know about the tangent graph. Okay, 1 second here. Minimize this as my last video. Okay, so let's take a look at the tangent graph. If we were to graph this here, we say, okay, so at 0, we were at a height of 0. So maybe we need to put some of these x values on the axis here. We say, all right, well, if this was like 2 pi here, 2 pi, then half of that distance would be pi. And we say, well, this would be pi halves here, pi halves. And this would be 3 pi halves. We don't have to necessarily mark those. And then here are pi fourths notch marks. But one thing I want to put on the graph first of all is this. We notice that at pi halves, we have an undefined spot. So we're going to put on this graph what we call an asymptote. Asymptote. And this is a line for which our graph will always approach but never collide with. We also had an asymptote when x was 3 pi halves. Okay? So another asymptote at that x value. We said when we plugged in an x value of 0, we were at a height of 0, so 0 zeros on this graph. When we were at pi fourths, we were at a height of 1. Okay? And so the right side, or sorry, this part of the graph was going to look like this, and it's going to get steeper and steeper, and it's always going to approach this asymptote that goes on up and up forever and ever, but never ever touch it. It's going to get close to it. So we say, okay, so at 3 pi fourths, which is, let's see here, 1, 2, 3 pi fourths, we were at a height of -1. Here she is. At pi radians, when we said tangent of pi, we got a height of 0. And then at, excuse me, 5 pi fourths, we were at a height of 1 again. So, and we knew that our graph was simply going to repeat itself. So here's the middle part of our graph here. Not very well drawn. Let's see if I can't do a better job of that. Looks like this. Okay? And so approaching the asymptotes. And then getting over here again, we'd say it'd again be down at a height of -1 and then back to 0. And so it would kind of look like this here, knowing that we can cut off our graph. But what you get is this graph that just keeps giving us these tangent lines and repeats itself over and over again over a pi's worth of span there on the x-axis, because pi is its period. That is, pi inputs, or a pi's worth of rotation, is how long it takes it to really repeat itself. I think a good thing to do here would be this. I think, you know, in the last couple of videos we graphed the graphs of sine and cosine. So let's try to include these here. What if we were to graph sine, the basic graph of sine? So at this point, you know, we want to just kind of memorize the basic graph of sine. It is this graph that goes up, then down, then down, then up. It looks like this. And then cosine, let's do cosine in a different color here. What if we do cosine in like a yellow? Say the graph of y equals cosine of x. Looks like this. It started up and then went down, then back up again. Okay. So we have these in our heads. Let's go ahead and graph sine. So we say sine, its period was from 0 to 2 pi. It does its thing. It starts down on the ground. Okay. A fourth of the way through its period, so that's at pi halves. It's up at a height of 1. Halfway through its period, it's back down to 0. 3/4 of the way through its period, it's down at a height of -1. And then it comes back up to a height of 0. So this would be the graph of our sine x graph here, kind of. And then we say, okay, so cosine starts up in the air at the beginning of its period. A fourth of the way through, it heads down to the ground level here, if you want to call it that. Halfway through, it's down here at a height of -1. 3/4 of the way through its period, it's back up to 0, and then it's back up to a height of 1 again at the end of its cycle. So we say, okay, so the graph of sine looks something like this. What I want to do is kind of look at how these kind of affect the graph of our tangent here. So what we know is this. We know that the graph of tangent is equal to sine over cosine. That is, in this instance, the height of the pink graph divided by the height of the yellow graph. So you'll notice this. If we start off with, say, sine here at 0, input 0, we say the height of our sine graph was at 0, okay, right there. So 0 divided by a height of 1, we say our tangent graph then is at a height of 0. And it was at a height of 0. Our green graph was at a height of 0 there. When we got out to here, you notice that cosine and sine, they're at the same height. So if we were to take the pink height divided by the yellow height, since they're at the same height here, we would get 1, and our tangent graph was at a height of 1. And then really importantly, you'll notice that cosine was at a height of 0 when we plug in pi halves. Okay? Why is that important? Because if I try to take this pink value divided by 0 here, this is why I'm getting an undefined spot. So you'll notice that the 2 times where our cosine graph is on the x-axis are the 2 times where our tangent graph had vertical asymptotes, because if we were to try to find tangent there, we would be dividing by a cosine value of 0. Okay? So now maybe looking over here at pi. Okay, if we say, what's the tangent of pi? Well, you notice that our green graph is on the x-axis. That is, it's a height of 0. Why? Well, because if I were to take the pink height, which was at a height of 0, the sine was at a height of 0, and divide by my cosine value, which was at a height of -1, 0 divided by -1 is 0. Okay? Even over here, we say it, it's kind of skewed, but we'd say if I were to take the pink height right here, divided by the yellow height, okay, I'd get, this is like radical 2 over 2 above, and this is like radical 2 over 2 below. And positive radical 2 over 2 on our pink divided by negative radical 2 over 2 on our yellow would give us negative 1. This is our height of negative 1 here. Okay. And so also we could come take a look at over in GeoGebra here. The pink graph here is our graph of cosine. So it starts up and then goes down, down, up in a 2 pi interval. And our sine graph is in blue. It goes up, then down, and back up again in a 2 pi interval. So if I were to now highlight our tangent graph, pardon me, there we are, you'll notice that we have asymptotes at pi halves and 3 pi halves because those are the two values for which our cosine was on the ground, okay? And so if tangent is sine over cosine, then if cosine is equal to 0 at those two spots, then we'd be dividing by 0 and getting something that's undefined, okay? You'll notice that our tangent graph was at a height of 1 about right here. It was at a height of 1 about right here. That's because if we were to take, say, the blue graph height right here and divide by the pink graph height, that's something divided by itself. In this case, I get a height of 1. And what's the value of tangent, say, over here? It was also at a height of 1, but that's because when we take the blue graph height, which is our sine graph, divided by the pink graph height, even though they're both negative, I'm dividing a negative number by itself, and I get a height of 1. Okay, so just to kind of zoom out a little bit here and give you an idea of what the tangent graph looks like, you'll notice that we get these, what we call them tangent lines. I joke with it, they're tan lines, okay? Like if you were to hang out on a beach, you'd have tan lines. But you'll notice that from pi halves to 3 pi halves, that is an interval of pi radians. So it does its thing within an interval of pi radians, and then just repeats itself every pi radians after that. From 3 pi halves to 5 pi halves, that is an interval of 2 pi halves to get from 3 pi halves to 5 pi halves, and 2 pi halves reduces down to pi. Okay, so every pi radians, our tangent graph is going to repeat itself. And as a matter of fact, we say tangent and cotangent are the only two graphs that have periods of just pi. Okay, so if you want to graph tangent, the best thing to do is make a table, but we also want to memorize the basic shape of this graph, okay, which is essentially this guy here. And from 0 out to 2 pi, we'd say it would look like this.